Hello there. How are you doing? Hope you're all doing great. Welcome to an episode of my English podcasts. My name is Parham, and we are going to learn English from any single material that is relatable to English, like films, actors, of course their speeches, books, quotes, and so on. And hopefully they could help you with English. So without further ado, let's dive into this episode. So, in the previous episodes, we were talking about some everyday topics, such as learning English with movies, anger, and different ways of managing it, personality and the way it's formed. However, today, we're going to dive into something different and quite special. Have you ever considered learning English with physics? Seems strange and difficult, right? But it isn't. I'm going to be talking about a branch of physics called thermodynamics. Those who are mechanically inclined might have already known enough of thermodynamics. But today I'm going to be talking about different elements involved in thermodynamics and different processes. And also, I'm going to be discussing two important laws of thermodynamics. So first things that we shall know about thermodynamics, or let's say two important things that let us understand it in a better way, are actually system and surroundings. Imagine an amount of air and a kind of like a container. So that air is called a system, and the container is the surrounding. So, the focus of thermodynamics is on a certain form of energy and the way it's converted into another form of energy. Because energy is never created nor destroyed. It kind of transformed into one form to another. So, particularly, we're going to be talking about heat and work in thermodynamics. We're going to see how relatable these two are to each other. Heat and work, and how heat could be converted to work, and how work could be converted to heat in thermodynamics. At first, we're going to dive into the first law of thermodynamics, which is directly about internal energy. As we all already know, internal energy is defined as a total kinetic energy and the potential energy. The combination of these two energies, we can call it internal energy. So, as I told you earlier, in thermodynamics, we're working on heat and work. So the internal energy equals something, the relation of Q and work. Q represents heat and W represents work. So when we just make changes in these two elements, there are some changes made in internal energy. So on the other word, we can say that, the key point is the conservation of energy. Because as I told you, it's never created nor destroyed. It is just transformed into one form to another. So, now we're going to see what exactly, what points are involved in thermodynamics. The first one is volume. We also got pressure, temperature, and heat. So by changing these things in the system, we can see that the internal energy, there might be some changes made in the internal energy. Because by changing each, the value of work, heat might be zero, and they won't be changed, in that system. So, but anyway, the value of, the changes of the internal energy always remains the same. It doesn't matter how many of those elements you want to change. anyways, the internal energy remains the same. So, there are different processes in thermodynamics. The first one is isovolumetric. In this case, volume just remains the same. The piston always, is always static. It doesn't move. So the value of work is 0. There's no work done by the system. And the other one is isobaric. This time, pressure remains the same. It doesn't change. And the other one is isothermal. It comes from temperature, so the temperature remains the same. It doesn't change. While we can see that heat is transferred into just a kind of bigger system. And the last one is adiabatic process. In this kind of process, the work is done so fast that there's no time to transfer heat into or even out of the system. So in this case, we can say that the changes in internal energy equals W, because there is no Q, there is no heat transferred. This is the story of the first law of thermodynamics, which focuses on internal energy and the elements and factors which directly affect the value of internal energy, while it always remains the same. And I mean, the changes in work and Q. I mean heat. The second law of thermodynamics is about entropy. We consider, everything that we see around us are either solid, liquid, or gas with different, we consider, entropy is a kind of shows how disordered something is. The more disordered, the more entropy. For example, we said that, let's consider a cup. It is solid, isn't it? So it's got, kind of less entropy than water that we can see on a glass. So we consider the liquid, the molecular of, water have got more entropy. They're always moving and hitting the glass. And they're more disordered than the moleculars of that cup I was talking about. So the more disordered, the more entropy. And another point is that, generally the second law of thermodynamics focuses on the fact that heat can spontaneously flow from something warmer to something colder. That's the point. Because, for example, let's consider a cup of tea, and you just, it is connected to a glass of water, something colder. So we can see that heat is, just transferred and flows to that cold water. It is called entropy. So it sort of suggests that heat flows from something warmer to something colder, and it can't be unlikely. It never spontaneously moves from something colder to something warmer. Is impossible. This is the law of thermodynamics this way. So the first one, if I want to summarize what I've said so far, the first one is about internal energy, Q, work, and different kind of processes. And the second one focuses on entropy. I actually didn't want to go deeper in thermodynamics because it could be sort of hard to understand if you don't know much about physics. Um, but let me know what you think about thermodynamics. Let me know if you knew what I've said in this episode. And if there's something interesting about thermodynamics you want to let me know, just write down in the comments and tell me how difficult it was for you to understand, or it was simple. Anyway, thank you for allocating your time to listening to my podcast, and bye for now.